for what size of conductor the cost is minimum. Okay, the cost of conductor is minimum. That means annual cost is minimum. Okay, that is given by Kelvin's law. We have seen that the most economical size of the conductor is that for which the cost of annual losses due to energy wasted in the conductor is equal to the variable part of annual charge. And the derivations we have seen, the graphical representation we have seen, we have discussed the limitations also of this Kelvin's law and some problems we have solved. Now today we will go through different systems of power transmission. Okay. Actually, one thing before starting the new topic, let me tell you, you are supposed to have offline classes from Monday. Okay.
Yes,
okay.
ma'am.
But next week I won't take your class. Next week means I will take your class on Friday only, even if it starts online, and maybe from 10, if it is not possible from 10, from 10:30 I will definitely take. Okay. Because you have scheduled class from 10, you cannot say that it will be difficult for us to attend at 10. If the class is at 10, you have to attend. Your actually class timing is 10, from 10 to 5 or 5:30. Anyway, so you have to come at 10. So I will allow you up to 10:30. Okay. So every week, if I take from 10:30 to 11 on 10:30 to 12 on every Friday, then I think I'll be able to complete my syllabus. Okay. So, but this week I won't take because I have heard that some students, they won't be able to come in the first week. Maybe from 14 they will be able to attend. Isn't it? What is your opinion? Because it becomes difficult. I won't take the attendance. That means what? That means many students will miss the class. And knowingly that many students will miss the class, if I take the class, I have to repeat the same thing. Is it okay to you? I'll start
yes,
the
ma'am.
online, but okay, thank you. But I cannot take the online class on Friday. Okay. Because it is notified that classes will be from offline. Okay.
Yes, ma'am. We can attend the class from Friday in offline.
Yeah, ma'am, but I think
no, not from
some
Friday.
of us
I am
will join
telling
after 14th.
Yes, I am telling that next week I won't take the class. Next week I will take offline class. Okay. In the meantime, if there is any development, or you feel that in the next week, that is Friday, you are interested in attending the online class, you have to write in my mail. I will take the online class instead of missing one class. You can attend that one. Okay, that you discuss amongst yourself. That whether on the next Friday, but next Friday I will not take offline class. Okay, either I will not take any class, or your request I can take online class. Anyway, you discuss. Friday is 1 week. Still 1 week is remaining.
ম্যাম আপনি আগের উইকে বলেছিলেন যে আমাদের ইন্ডিয়াতে হাইয়েস্ট ট্রান্সমিশন ভোল্টেজটা কত হতে পারে। ম্যাম ওটা কি 800 ডিসি হবে?
না, ডিসি আর এসি কিন্তু আলাদা আলাদা ভোল্টেজ।
ইয়েস ম্যাম, মানে 800 কেভি ডিসি একটা দেখলাম যে ট্রান্সমিশন ভোল্টেজ রয়েছে, আর এসির ক্ষেত্রে 765 কেভি দেখলাম। ওর থেকেও কি বেশি হয়?
আমার মনে হচ্ছে যেন আমি 1200 একটা দেখেছিলাম। একটু দেখো তো, আরেকটু স্টাডি করো। ঠিক আছে, ডিসি আর এসি আরেকটু স্টাডি করো। আমি একটু দেখে ওটার লাইনটা এতদিনে তো in use হওয়ার কথা, it was under construction. Okay, I will let you know. Anyway, so transmission of systems of power transmission. So there are kind of two types of transmission. First, DC and AC, all of you know, broadly classified. It can be DC and AC, and you have seen that HVDC transmission. It is very popular nowadays because it has been seen that there are many advantages for DC transmission under high voltages. So what is done at the generation is done in AC, and then it is converted into DC, then transmission is done at DC, and again at the consumer premises, it is converted into AC. Okay. So DC system, then single phase AC system. You are conversant with single phase AC system, then two phase AC system, though it is not very common in use, and then three phase AC system. Okay. Three phase AC system, you know, three phase AC system means the voltages are displaced from each other by 120 degree, and in two phase AC system, the voltages are displaced from each other by 90 degree. Okay. And of course, under balance system, the magnitudes of all voltages of all the phases are constant. Now, we will be studying, consider only the balance system. Okay, it is not like that the system remains always in balance. It is not possible. The loads in all the phases are exactly equal. But severe unbalancing is not allowed. Okay, unbalancing up to a certain percentage is allowed, and precautionary measures are taken to reduce unbalancing if the unbalancing is more. Okay, so for derivation purpose, we'll consider balanced load. Balanced load means, you know, in DC there is balance, unbalanced, and no question arises. For AC single phase also it does not arise. For AC three phase, you know, if it is balanced, then the current through the neutral wire is zero. That means IA plus IB plus IC is zero. So, and for AC two phase AC system also, IA plus IB, what will be IA plus IB? That I will come later on. Or only for this system it is not zero. Anyway, I will come later on. So what are the divisions? Let us quickly go through. First, DC system. In DC system, there are three subdivisions. One is DC2 wire, one is DC2 wire with midpoint earth, another is DC3 wire. Okay. So then single phase AC system, single phase 2 wires, single phase 2 wire with midpoint earth, single phase 3 wire. So let us go to the schematic diagram. See, this is the DC 2 wire system. One wire is always earth. And then next one is DC 2 wire system with midpoint earth. You can see the let me reduce this one. See, it is midpoint earth means this point is earth. Okay, but the wires are two. This is one wire, this is another wire. This is go wire, this is the return wire. Now third one is this is a DC3 wire. That means the earth wire is available. Okay, this is the difference. And similar is for AC single phase also. So let us go through one by one. Now what exactly we are wanting to study? We want to study what will be the volume of conductor material for each system. Now volume of conductor material means, you know, it is cross-sectional area into the total length. Now the total length of the transmission line, that we will consider constant, because, you know, it should be constant. It is not no point in comparing the volume of conductor material for 10 kilometer line and 100 kilometer line. Obviously for 100 kilometer line it will be more. So the length of the transmission line will be constant. So if the length of the transmission line is constant, the remaining thing is only cross-sectional area. So it is all about cross-sectional area A. Okay. If A is less, then the volume of conductor material requirement will be less. Okay.
But also the number of wires will vary, no, for different systems.
That will vary. So for considering the volume, if it is 3 wires are there, it will be 3 into A into L. If 2 wires are there, it will be 2 into A into L. Okay. So
yes, ma'am.
It will be like that. So DC system, 2 wire system. Achha, for that one now, what are the things that should be kept constant? First, I told you the length of the line will be kept constant. And the power transmitted, obviously, if the power transmission requirement is more than cross-sectional area requirement may be more. So it is, so we will be considering the power delivered should be constant. That P should be constant. Air is constant and the total loss in the line is considered to be constant. For the same amount of loss, we'll consider the volume of conductor material. Now, the another important thing, the voltage. Okay. You know, you have seen that for high voltage transmission, the amount of conductor material requirement will be less. So, the voltage should be kept constant. Okay, so 4 things will be kept constant. That means we will express the volume of conductor material in terms of all these 4 quantities: P, L, P loss and V. Now for V, there are 2 rules. We will be studying today the overhead lines. We will be studying underground conductables in the next class. But the treatment, but the consideration of voltage will be different for these 2. That means for overhead lines, what we'll consider? We'll consider the maximum voltage between each conductor and earth to be constant. But for underground cables, the maximum voltage between 2 conductors should be kept constant. You can understand. For DC, there is no problem. But sorry, for DC also there is a problem. I'll come just now. But let me discuss why this difference. In overhead lines, we are considering the maximum voltage. Why maximum voltage? In DC, there is no problem. Maximum and the ordinary voltage all are same. That is only one value. But for AC, if we say V, it is the RMS. If we say Vmax, it is the maximum. So the maximum value is considered to be constant. Okay. So for DC, what will be the power? Power will be V into I. But for AC, what will be the for DC power will be Vmax into I. But for AC, it will be Vmax by root 2I cos theta. This difference you must remember. Okay. Now, why for overhead lines, it is the voltage between conductor and earth. The overhead, you know, in overhead transmission lines, the insulation is not required. Okay. Insulation is not required, but when they are terminated at the towers, they must be insulated from the towers which are directly connected to the ground. Okay. So the voltage between one conductor and earth is considered in case of overhead transmission lines. Clear? Voltage, yes?
Ma'am, in the tower, which wire is used to prevent the earthing problem and then repeat once?
No, not which wire. The wires are terminated at the towers. You have seen that insulators are there. Pin insulators, suspend, different types of insulators are there. Porcelain insulators are there. They are connected to the towers through the insulator, so that towers are erected on the ground. So the wires should not be connected to the ground. Okay, but they need to be supported by the towers. So what is done? They are connected with the help of insulators. So they do not get touch with the ground. Okay.
না বলছি টাওয়ারে যে চিনেমাটির যে জিনিসগুলো মানে গোল গোল থাকে ওইগুলোই কি মানে ইনসুলেটর হিসেবে ইউজ হয়?
হ্যাঁ ওগুলোই। হ্যাঁ, ওগুলো পিন ইনসুলেটর আর বড় বড় এগুলোতে সাসপেনশনটা দেখবে অনেকগুলো ডিস্ক পর ঝুলছে বড় বড় টাওয়ার গুলোতে।
ইয়েস ম্যাম।
আচ্ছা।
ঠিক আছে, ওগুলো ডিটেইলসে তোমরা ইনসুলেটরস পড়বে।
ইনসুলেশন তো ভোল্টেজের উপর ডিপেন্ড করে, ওই জন্যই ওই
ভোল্টেজের উপর ডিপেন্ড করে। আর ট্রান্সমিশন লাইন দেখো, আমি 3 ফেজই ধরছি। 3 ফেজের দুটো কন্ডাক্টরের মধ্যে ভোল্টেজ কত হবে? এটা তো লাইন ভোল্টেজ, তাহলে √3 টাইমস দ্য ফেজ ভোল্টেজ। কিন্তু সেই ভোল্টেজটা আমাদের নেওয়ার দরকার হয় না ওভারহেড লাইনে। নেওয়ার দরকার হয় না মানে কি, আমি যেই ট্রিটমেন্টটা করছি সেখানে আমার ধরা দরকার হচ্ছে না। সেখানে আমি কি ধরছি, সেখানে আমার ইম্পর্টেন্সটা কি হচ্ছে, যেহেতু ইনসুলেটরটা আমি একটা আর্থ আর একটা ফেজের মধ্যে ইনসুলেটরটা দিচ্ছি, সেই জন্য আমি ওই ফেজ ভোল্টেজটা মানে বিটুইন দ্য কন্ডাক্টর এন্ড দ্য আর্থ উই আর কনসিডারিং।
Yes ma'am.
But for underground cables, why? In underground cables, it is beneath the earth. That means lots of insulation is to be provided. Okay, and the maximum voltage, of course, will appear between 2 conductors. So there, the voltage between the 2 conductors will be considered. Okay, because the insulation is provided on the basis of the voltage, maximum voltage, and the maximum voltage occurs between the two conductors. So for underground cables, we'll consider the voltage between two conductors. See, whatever I told is written here. You please go through it. Your overhead line, transmission lines, conductors are insulated from the cross arms and supporting towers. Since the towers and cross arms are earth, therefore the maximum voltage between each conductor and earth forms the basis of comparison of volume of conductor. And for transmission by underground system, in underground system, the maximum disruptive stress is between the conductors. So the maximum voltage between the conductors forms the basis of comparison. Okay, so this difference in treatment you can understand when we'll discuss, but let us start the DC system. First category, this is two-wire system with one conductor earth. So this is the, let us consider this is the go wire, this is the return wire, this is earth. Now maximum voltage, I have told that we'll consider the maximum voltage, otherwise there will be some error. Okay, either you consider the RMS voltage or you consider the maximum voltage. Okay, here the maximum voltage is considered. So maximum voltage is considered Vm, power to be transmitted constant P, length is considered L, and another thing, P loss is considered to be same. Now if Vm is the voltage, P is the power, what will be the power? Power will be Vm into I. Here it is called I1 because this is the fast system we have considered. So I1 will be P by Vm. Now what is I1? What is power loss? Power loss will be 2I1 square R because two conductors are there. The loss will occur in both the conductors. So it will be 2I1 square R. And what is R1? R1 is rho L by A. See, these steps will be followed in all the cases. There are 10 cases, so 10 types of systems. So this method will be followed for all the 10 types of systems. So this is 2I1 square R. So R1, so substitute I1 from here, substitute R1 from here. Ultimately, you will be getting this one. Okay, 2 P squared rho L by Vm squared A1, that is P loss. Now you see, we can express A1 in terms of P loss, P, rho, L, Vm, and all are constants. We have considered all these things constant, P, L, P loss, Vm, and rho is also, of course, constant. We'll consider the same material. So the cross-sectional area, due to the cross-sectional area, we are getting this one. Now, volume of conductor material. What will be the volume of conductor material? How many conductors are there? This is one conductor. Huh? 2. So, 2 into A1 into L. So, this is the volume of conductor material required. 2 into A1 into L. This is coming this one. All are constants. We are considering it to be K. And we'll express the volume of conductor material of all the other transmission systems in terms of K. Then we can compare actually. Okay. If we can express all other conductors volume in terms of K. So I hope this is the simplest system. There is no problem here. Now what is the second system? Second system is the DC2S system with midpoint earth. Now Vm, we can consider Vm to be the voltage between this conductor and this conductor. But why they have considered between this point and this point? Because for overhead transmission line, it has been mentioned. What is Vm? Vm is the voltage between the conductor and the earth.
Yes, ma'am.
Okay.
Yes, ma'am.
So,
Yes, ma'am.
so this is the like this. But for overhead transmission line, underground cables, I just show you. For underground cables, see, it is the voltage between two conductors. No question of earth point. So here the treatment is different. Okay. So
Yes, ma'am.
Yes, sir.
So for overhead transmission lines, this is the voltage. This between this conductor and this earth point, this is the voltage Vm. So this you must be careful about this. So if you are asked to compare the volume, you must be careful which system it is, overhead or underground. Okay. Now other treatment is exactly same. If we consider this is VM, this will be twice VM because it is a. So the treatment is same. This is twice VM. So what is P? P is equal to twice VM into I2. We consider this one as I2. Okay, second system. So it is twice VM I2. So what is the power loss? Here midpoint is earth, but this wire is not available. Earth wire is not available. So the power loss will be 2I2 square into earth. Okay, then substitute I2 from here. And R2, it will be rho L by A2. So it will be this one. Now area of cross section, what will be the area of cross section? So just take A2 on the left hand side. This is A2. So where the difference has occurred? Difference has occurred at this point. In the previous one, it was just VM, but here twice VM. Then what is the volume of conductor material? Twice into A2 into L. Okay, so twice into A2, you substitute from here A2 into L, so it will be like this. So K, in previous one we considered K, it was like this. Here term 4 is not there, so we can write it as K by 4. So you can understand the volume of conductor material requirement will be less in case of DC 2S system when the midpoint is earth. In case of overhead line, okay, it is not for underground cables. In the underground cables, you can see that both will be same because if there is no difference here, both should be same. Okay. So
Yes,
and the
ma'am.
wires, remember, wires are only 2. So we have taken 2 into A2 into L. Now the third one, what is the difference? 3-wire system. 3-wire system, that means this earth wire is available. You see, everything is same, but this wire is available. Now see, I have told that we are considering balance system. Balance system means whatever current I3 is going out, here I3 is coming in. Same current. So what will happen? What will be the current through this wire? This is called the neutral wire. Current through this neutral wire will be 0 under balanced condition. Okay. Now,
Yes, ma'am.
I have told that under normal, in practice, it is not like that. The system is always under balanced condition. Some unbalancing are there, but it is very less. Now, yes.
ম্যাম বলছি এটা কি মানে এটা কি আর্থ করা নাকি গ্রাউন্ড করা ম্যাম? মানে আর্থ আর গ্রাউন্ডের মধ্যে কি কোনো ডিফারেন্ট আছে? যে এই যে মানে ব্যালেন্স সিস্টেম 3 ফেজ 3 বার ডিসি ব্যালেন্স সিস্টেমে
না, গ্রাউন্ড এখানে গ্রাউন্ড করা, এটা হচ্ছে আর্থ ওয়্যার, কোনো ডিফারেন্স তো নেই।
আচ্ছা আচ্ছা। আর একটা কোশ্চেন ছিল।
হ্যাঁ
ম্যাম, ওই সেকেন্ডারি যে ডিস্ট্রিবিউশন বলেছিলেন যেটা হচ্ছে ওই আমরা 33/11 যেটা সাবস্টেশন থেকে যেটা কনজিউমারের বাড়িতে যেটা যায় ফিডার যেটা হয় 11 কেভি ফিডারটা, ওখানে 3.3 কিলো ভোল্টটা কেন স্ট্যান্ডার্ডাইজ করা হয় না? আমরা কেন 11 ভোল্টেজ হবে কেন স্ট্যান্ডার্ডাইজ করি ম্যাম? অনেক বইতে লেখা আছে 3.3 কিলো ভোল্টটা স্ট্যান্ডার্ডাইজ না, কিন্তু কেন না ওটা?
না শোনো, 3.3 কেভি।
হ্যাঁ ম্যাম, দেখো
যে কোনো জিনিস কেন নয় সেটা তো অনেক 11 জায়গায় অন্য ভোল্টেজ করা যেতেই পারে। এখন 11টাকে স্ট্যান্ডার্ড ধরা হয়, ঠিক আছে? এবার কোনো জায়গায় তোমার একটু অন্য ভোল্টেজ থাকতে পারে, কিন্তু ট্রান্সফরমার বা অন্য যে ইকুইপমেন্ট গুলো সেগুলো সব 11 ভোল্টে। কিন্তু তোমার 3.3 কেভি কোথায় পেয়েছো? 11 কেভি থেকে তো আমি বলেছিলাম বড় বড় কনজিউমাররা 11 কেভি থেকে ডাইরেক্ট ভোল্টেজ নেয়, ওকে? কিন্তু এমনিতে তোমার ওটা 400 বলছে, স্টেপ ডাউন করার পরে তোমাদের ওই সার্ভিস মেসটা 400 ভোল্টস থেকে আসে। ওটা 3.3 কেভিও নয়, 11 কেভিও নয়।
ঠিক আছে, ঠিক।
হ্যাঁ, মানে ধরো এই যে এখানে দেখবে যে এখানে যে 33/11 এই যে 132, প্রথম কথা এটা যে 132 থাকে তার সেরকম নয়, এটা একটা দেখানো হয়েছে, অনেক ভোল্টেজ থাকতে পারে, ঠিক আছে, সেটা রিকোয়ারমেন্ট অনুযায়ী কতখানি ডিস্টেন্স তুমি ট্রান্সমিট করবে, অনেক কিছুর উপর ডিপেন্ড করে। অনেকগুলো স্ট্যান্ডার্ড ভোল্টেজ লাগবে, ঠিক আছে। যে কোনো তুমি যদি একটা ইকুইপমেন্ট কিনতে চাও, ইলেকট্রিক্যাল অ্যাপ্লায়েন্স কিনতে চাও, তুমি নিশ্চয়ই যে কোনো রেটিং এর পারবে না, তোমাকে একদম ফিক্সড পাওয়ার রেটিং কিছু আছে, সেই রেটিং এই তোমাকে কিনতে হবে, ঠিক আছে। শুধু ইলেকট্রিক্যাল ইকুইপমেন্ট কেন, কিছু যে কোনো কিছু কিনতে গেলে একটা পার্টিকুলার সাইজই তোমাকে কিনতে হবে, নাহলে সেটা ফিট করবে না, ঠিক আছে। তো এখানেও হ্যাঁ দাঁড়া আমি বলে নি, এখানেও যে 132 হবে সেরকম না, 220 400 কেবি এরকম নানা রকম হতে পারে, ঠিক আছে। এখানে 132 তো 33, এটা অনেক সময় 66 হতে পারে 33 জায়গায়, কিন্তু এইখানে যখন হবে এটা 66 to 11 হতে পারে, কিন্তু এই প্রাইমারি ট্রান্সমিশন ডিস্ট্রিবিউশনটা 11 কেবিতে হয়, আর সেকেন্ডারি ডিস্ট্রিবিউশনটা 400 এ স্টেপ ডাউন করার পর হয়। হ্যাঁ বলো
ম্যাম, যেটা ডিসি সিস্টেমে যেটা হয় না, সেটা কি স্ট্যান্ডার্ডাইজ ওয়্যার ইউজ হয় নাকি সলিড ওয়্যার ইউজ হয়? কিন্তু ম্যাম ডিসি সিস্টেমে তো সলিড ওয়্যারটা ইউজ না করাটা বেশি ভালো, কেন কিনা ওখানে তো স্কিন এফেক্টের কোনো প্রবলেম নেই। তো সেই ক্ষেত্রে কি ইউজ করা হয় ডিসি সিস্টেমের ক্ষেত্রে, স্ট্যান্ডার্ডাইজ না সলিড ওয়্যার?
স্ট্যান্ডার্ডাইজ ওয়্যার বলতে কি বলতে চাইছো? স্ট্যান্ডার্ডাইজ
ম্যাম এসি সিস্টেমে যেটা হয়, মানে স্কিন এফেক্টটা রিডিউস করার জন্য মানে স্ট্যান্ডার্ডাইজ করা হয়
স্কিন
ওয়্যারটা।
এফেক্টটা রিডিউস করার জন্য এসি সিস্টেমে যেটা ইউজ করা হয় সেটা হচ্ছে
Standard wire.
এসিএসআর কন্ডাক্টর। হ্যাঁ
কিন্তু ম্যাম ডিসি সিস্টেমে কি ওইটি সেমটা ইউজ করা হয়?
না, ডিসি সিস্টেমে তোমার স্কিন এফেক্টের দরকার পড়ে না, স্কিন এফেক্ট হয় না, ঠিক আছে। এসি সিস্টেমে একটা কি করা হয় আমি বলছি, সেটা এই সেমিস্টারে পড়াবো যখন আমাদের একটু কন্ডাক্টরও আছে। স্কিন এফেক্ট আমি বলেছিলাম তো, বাইরে দিক দিয়ে কারেন্টটা কনসেন্ট্রেটেড থাকে, তাহলে ভেতর দিকে হ্যাঁ ভেতরে একেবারে কারেন্টটা যায় না, সেই জন্য অ্যালুমিনিয়াম কন্ডাক্টর স্টিল রেনফোর্সড করা হয়, মানে ভেতরের পার্টটা স্টিল দেওয়া হয়, বাইরের পার্টটা অ্যালুমিনিয়াম দেওয়া হয়। অ্যালুমিনিয়ামের তো মেকানিক্যাল স্ট্রেংথটা খুব কম, সেই জন্য স্টিলটা দেওয়া হয় মেকানিক্যাল স্ট্রেংথটা বাড়ানোর জন্য। আবার ভেতরের পোর্শনটা স্টিল থাকে, সেই জন্য রেজিস্ট্যান্স যখন তুমি ক্যালকুলেট করবে স্টিলটা কনসিডারই করা হয় না, শুধু অ্যালুমিনিয়ামের রেজিস্ট্যান্সটা কনসিডার করলেই হয়, ঠিক আছে। তো এসিএসআর কন্ডাক্টরটা হচ্ছে অ্যালুমিনিয়াম কন্ডাক্টর স্টিল রেনফোর্স। বেশিরভাগ সময় স্টুডেন্টরা বলে অ্যালুমিনিয়াম কোর স্টিল রেনফোর্স, ইট ইজ টোটালি রং। কোরটা কিন্তু অ্যালুমিনিয়াম থাকেই না, কোরটা হচ্ছে স্টিল। আরো কন্ডাক্টর আছে, ঠিক আছে, আমি তোমাদের একটা নোটস দিয়ে দেবো, সেগুলো নানা রকম কন্ডাক্টর। আচ্ছা যাই হোক, তো হ্যাঁ এবার এখানে ডিফারেন্স, আমি শুধু ডিফারেন্স কোন জায়গায় বলছি, প্রথম থেকে ট্রিটমেন্ট ইট ইজ এক্স্যাক্টলি সেম দ্য ইনিশিয়াল ট্রিটমেন্ট, বিকজ দ্য ভোল্টেজ ইজ টুয়াইস Vm, so P equal to twice Vm into I3. Okay, so twice Vm into I3, so express I3 in terms of this one. Then what is line loss? Line loss is 2I3 square R. Why you are considering only line loss in the two conductors? Because I have told that current will not flow through here. We are considering balance system. Okay, so loss will occur only here and here. So now express A3 in terms of all these quantities. Now, volume of conductor material. Here actually 3 conductors are there. If there is one conductor, there must be some volume. Okay, so we have to consider the volume in the third conductor also.
Yes,
but what is the general rule? General rule is cross-sectional area is provided on the basis of current density, if not otherwise mentioned. Okay. Current density means if the current density means current per unit cross-sectional area. Okay. So if the current is more in a conductor, cross-sectional area provided should be more. Isn't it? If the current is less, cross-sectional area should be less. This is the thumb rule. Okay. So in the neutral, how to consider? No current is flowing. So we cannot say that no current is flowing, so zero cross-sectional area. That is not possible because no wire is provided. Generally, as the current in the neutral wire is very less, it is not zero exactly, but it is very less compared to the outer conductors. These conductors are called outer conductors. So as the current in the neutral wire is much less compared to the outer conductors, the cross-sectional area considered is only half of the outer conductors. Okay. শুধু শুধু তো আমি একটা মোটা তার দেবো না যেটার মধ্যে দিয়ে আমার কারেন্ট খুব কম, আমি জানি কারেন্ট খুব কম যাবে, ঠিক আছে, কারেন্ট কখনোই বেশি যাবে না, কারণ শুধু যে বেশি গেলে অনেক রকম প্রবলেম আছে, সেই জন্য কারেন্ট যাতে বেশি না হয়, বেশি সিভিয়ার অ্যানালাইসিস না হয়, সেই জন্য নানা রকম মেজার নেওয়া হয়। সুতরাং আমি শুধু শুধু একটা মোটা তার দেব না। So the cross sectional area is considered half. Okay, so see volume here instead of 3, আমি যদি একই cross sectional নিতাম, area নিতাম, এটা 3 নিতাম, instead of 3 it is considered 2.5 into A3 into L3. Clear? If it is not mentioned, in some problems you'll find it is mentioned 3 conductors of equal cross sectional area, then you have to consider thrice into A3 by into L. But otherwise this is the norms. Okay, the other things are same, so this is coming as 5 by 4. This one 5 by 4 means 1.25, I think. Why it is 5 by 16? Oh, in terms of K, it is 5 by 16. That means 0.3 something. 0.3 something K. So if you consider the DC system in terms of the volume of conductor material requirement, this system is most economical. Then the volume of conductor material. হ্যাঁ বলো
ম্যাম, আগেরটা বেশ ইকোনমিক্যাল ছিল না, যেখানে আর তো একটা ছিল না, সেটা তো ম্যাম K/4 ছিল।
হ্যাঁ সেটাই তো বলছি, K/4 মানে 0.25।
ইয়েস ম্যাম।
হ্যাঁ এটা সবচেয়ে কম, তারপরে এইটা, তারপরে প্রথমটা। ঠিক আছে, দাঁড়া কি একটা হ্যাঁ তারপর প্রথমটা। ওকে, নাও সেম ডিভিশনস ফর AC single phase system. So AC single phase system, 2-wire system. So 2-wire system, one conductor is earthed. So what I have told that you have considered Vm to be same. So for power, what you have to write? Vm by √2 I cos theta. Don't forget that. So what is P? P is equal to Vm by √2. This is I4 cos phi. So now express I4 in terms of this one. It will come this one, because I have told P equal to Vm by √2 I4 cos phi. So express I4 like this. The other treatment is exactly same. Only 2 wires are there. So twice I4 square R4. And then express A4 in terms of all these quantities. So what is the extra term coming here? Cos phi. Okay. So in terms of K, it is coming as twice K by cos square phi. So you know the power factor is always very high. It is tried to keep as close as unity. So it is 2K by cos square phi. It is slightly less than unity. So this is the for AC 2-wire system with one conductor earth. Then the next one, single phase system with midpoint earth. Okay, here also the initial treatment will be same. Midpoint is earth, but no earth wire is not available. So all this treatment will be same. For volume also, treatment will be same, but this will be Vm. This will be twice Vm. So what is the power? Power will be twice Vm by √2 I5 into cos phi, isn't it? It will be twice Vm by √2 I5 into cos phi. So here there will be difference. In the previous one, this 2 was not there. So other treatment is exactly same. Only 2 conductors are there, 2 I5 square R5. Then you express A5 in terms of this one. Then volume of conductor material requirement will be this one. Okay. So ultimately you will be getting K by 2 cos square phi. Okay, in the previous one, it was twice K. That means it is again 1/4 of the previous one. Just like the DC system. Second system was 1/4 of the first system. Here also it is 1/4 of the first system. Now third one, it is third wire is available. AC 3-wire system. This wire is available. So initial treatment is exactly same. It is again twice Vm. Okay. You just consider, they have considered like this, but you don't write like this. You write P equal to twice Vm by √2 I cos phi. Okay. Don't write this Vm by √2 RMS value of voltage between outer and earth like this. You write like that. Okay. So ultimately, where the difference will come? Difference will come here. Instead of 2, you have to consider 2.5. Okay.
Yes, ma'am. Yes,
It
ma'am.
is 2.5. So ultimately you'll be getting 5 by 8. 5 by 8 means 0.6 something, isn't it? So if we consider only AC single phase system, which is more what the conductor material requirement will be least. This is third one is 0.6, it will be 0.5. So again, the second system is most economical, then comes the last one, then comes the first one. It follows the same as that of DC. Now this is new to you. AC two-phase 4-wire system. So AC two-phase system, what I told that in two-phase system, one voltage is lagging with respect to another by 90 degree. So if one is in the x-axis, other will be, you can imagine that if VA is in the x-axis, VB will be in the y-axis. Okay. And there are two methods for AC two-phase system. What are the two methods? The two methods are two-phase 4-wire system, another is two-phase 3-wire system for AC two-phase system. So two-phase 4-wire system is simple. You can understand that 2 wires for each phase. For one phase, this is one wire, this is the other wire. So if the current I7 is entering here, it will be leaving through here. This is the two conductors for the other phase. Current I7 is entering here, leaving through here. And this midpoint is earthed. Okay, the joining point is earthed. Okay, that means midpoint of this is earthed, this point of this is earthed. Now, as it is a two-phase system, you think about three-phase system. What we consider for three-phase system, we calculate everything in per phase basis. That means what is the power per phase? Per phase power will be VA, V phase, I phase, cos theta. What is the total power? Thrice V phase, I phase, cos theta. Okay. So what is the power per phase? Per phase power is total power by 3, P by 3. Okay. And power is considered to be constant. This is the total power is considered a constant. Okay. P is the total power, remember. So what is the power per phase here? There are two phases. So power in this phase is P by 2. Also the power in this phase is P by 2. So let us calculate everything in terms of per phase power. So per phase power is P by 2. Now what is the voltage? Voltage, let us consider this phase because two phases are identical. All the values, magnitudes are equal. There is phase difference, but magnitudes are equal. Phase difference will not matter here. Okay. So this point is earth. This voltage between this outer conductor and this point is Vm. So what is the total voltage is twice Vm. So what is the voltage across this conductor in this phase? It is twice Vm by √2. Okay. And the load supplied by each phase is P by 2. Okay. So what is P by 2? P by 2 is twice Vm by √2 I cos phi. Understood? You can write it like this way. As we consider in three-phase system, what do we write? P by 3 equal to V phase, I phase, cos theta. Here also, P by 2 equal to V phase, I phase, cos theta. I is same, I7. And what is V phase? V phase is twice Vm by √2. So it is coming as twice Vm. So you write down, first step you write like this. P by 2 equal to twice Vm by √2 I into cos theta. Why twice Vm? Because here the voltage is Vm, so this is twice Vm, and this √2 for converting the maximum value to RMS value. And this P by 2, this 2 is to convert the total power into per phase power. Any problem here? Understood? What will be the first step?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Now you start, you can express I7 in terms of P, Vm and cos phi. What is the loss? Now loss, how many?
P by 2 টা একবার বলুন না।
হ্যাঁ, P by 2 হচ্ছে যেমন বললাম সবসময় থ্রি ফেজটা ভাববে, যেহেতু টু ফেজটা নতুন, থ্রি ফেজে কি হবে, তুমি কি ফর্মুলা ইউজ করো? দুটো ফর্মুলা আছে, টোটাল পাওয়ার P মানে কিন্তু সবসময় টোটাল পাওয়ার P equal to √3 VLIL cos theta অথবা it is p equal to 3 v phase I phase cos theta অথবা উল্টো ভাবে ভাবি v phase I phase cos theta equal to p by 2 তার মানে কি p by 3 তার মানে কি পার ফেজ পাওয়ার হচ্ছে p by 3 v phase I phase cos theta এখানে ঠিক তাই পার ফেজ পাওয়ার মানে হচ্ছে p by 2 that is equal to v phase I phase cos theta ঠিক আছে সেই জন্য p by 2 টোটাল পাওয়ারটাতে আমি কনস্ট্যান্ট ধরেছি p আর এটা হচ্ছে টু ফেজ তাহলে একটা ফেজে পাওয়ার হচ্ছে p because it is a balanced system. Okay.
Yes, ma'am.
So this is the now line loss. There are 4 lines and all are carrying equal amount of current. So it will be 4I7 square R7. So you just substitute I7 R7 here. And what is the volume of conductor material requirement? Volume of conductor material requirement is 4A7 into L because 4 conductors are there. So it is like this and therefore the total is coming as K by 2 cos square phi. Okay. So this is the volume of conductor material requirement for two-phase AC, two-phase four-wire system. Later on, we will make a comparative study of all the systems, okay, in terms of cross-sectional area in a tabular forms that you can see which one is most economical. But it is not like that. If it is most economical in terms of the cross-sectional area, then only that will be used. There are other criteria also. Now, another AC two-phase system, that is AC two-phase three-wire system. See, just like in three-phase system, 6 conductors are not used, isn't it? They are connected either in star or in delta.
Yes,
In
ma'am.
AC two-phase system also it is possible. Instead of 4 conductors, 2 for each phase, it is possible to use 3 conductors also. Okay, 1 neutral conductor. That means this phase and this phase, they are joined together to the earth and another conductor, neutral conductor is taken. But what is the difference in 3-phase and this system? Okay. I thought we will be discussing it at the end anyway. Till now you have seen that for DC also you have seen that for AC single phase DC you have seen that we have considered current here to be 0, almost 0. Therefore we considered here cross section area to be 0.5 only, isn't it?
Yes, ma'am.
This is
Yes,
for
ma'am.
AC. This is for AC. This is for DC. You have considered current through the neutral conductor to be 0 under balanced condition. But here it is completely different. You think of 3-phase system. In 3-phase system under balanced condition, IA plus IB plus IC. If we
0.
add them vectorially, that is always 0, isn't it?
Yes, yes, ma'am. Yes, ma'am.
You draw IA in the y-axis, then 120 degree lagging, you draw IB, 120 degree still lagging, you draw IC. If the magnitudes are equal, the total resultant is 0. So the current through the neutral wire is 0. But here, is it possible? 2 phases are there, one different phase difference is 90 degrees. So you draw one in the x-axis IA and IB you draw in the y-axis with the same magnitude. Then can you say IA plus IB equal to 0?
No, ma'am. Root 2 times.
No, ma'am. It will never be equal to 0. If their magnitudes are equal to, each is equal to I8, then what will be the magnitude of the resultant?
Root 2 times of I.
And the phasor addition of the two currents.
Yes.
Yes, phasor addition of the 2 currents. So it will be always root 2 into I8. So what will be the current through the neutral wire? It is more than the current through the outer wires. So will it be justified if you consider less cross-sectional area? It is not justified. We have to consider more cross-sectional area because more current is flowing. And what will be the cross-sectional area if you consider the same current density? That means if the current becomes 2 times x times, the cross-sectional area should also be x times more. So here, if we consider cross-sectional area to be 8, the cross-sectional area in the neutral wire should be root 2 into 8. Okay, to provide the same current density. And
Yes, ma'am.
if the cross-sectional area is √2 into 8, what will be the resistance? Resistance will be R8 by √2. Isn't it? Resistance is inversely proportional. If
ma'am.
cross-sectional area is increased by x times, resistance will be decreased by x times. So these things you have to keep in mind. Okay. Now let's start.
Ma'am, one
So-
question.
Bolo.
Ma'am, why in two-phase the phase angles are not kept at 180 degree? Then it should cancel each other. Why they are kept at 90 degree?
না 180 ডিগ্রি মানে কি যে ইয়ে দিয়ে ঢুকবে আরেকটা দিয়ে বেরিয়ে যাবে ওটা তার ফেজ ডিফারেন্সের কোনো মানে হচ্ছে না 180 ডিগ্রি মানে কি এক্স্যাক্টলি অপোজিট
Yes,
ঠিক
ma'am.
আছে তুমি যে একটা ডিসি
Yes,
টু ওয়্যার
going path আর return path এর মধ্যে।
রিটার্ন পাথ ডিসি টু ওয়্যার এর
Okay.
মতো ঠিক আছে
Yes,
আচ্ছা
ma'am.
এসি সিঙ্গেল ফেজ একটা দিয়ে ঢুকছে একটা দিয়ে বেরোচ্ছে ঠিক আছে সেই জন্য এটাকে 90 ডিগ্রি ধরা হয় টু ফেজটাকে 90 ডিগ্রি বলা হয় আচ্ছা নাও so what is the voltage considered? Voltage will be considered between the any one outer conductor and the earth point. Okay, this is Vm. This is also Vm. So what will be the voltage? Voltage will be Vm by √2 RMS voltage, and current, what will be the per phase power? Similar to the previous one, per phase power is P by 2. So
Yes.
P by 2 will be equal to Vm by √2 I cos phi. This is very simple. The per phase power is P by 2. What is the per phase power? That is Vm by √2 into I8 cos phi. Okay, so from there we are calculating what is I8. Now this is okay. Now current in the neutral wire, I have told that it is twice √2 into I8 under balanced condition. Now assuming the current density to be constant, the area of cross section of the neutral wire is √2 times that of the either of the outers. Okay, so the outers, as the neutral wire carries √2 times the current in each the outers, its cross-sectional area must be increased in the same ratio to maintain the same current density. Okay, so the
Yes, ma'am.
cross-sectional area of the neutral wire is considered to be √2 8, where 8 is the cross-sectional area of the outer conductors. Now, resistance of the neutral wire, I have told that if the cross-sectional area is increased by √2 times, resistance will decrease by √2 times. So if the resistance of the outer conductors is R8, the resistance of the neutral wire is R8 by √2. Okay, so it is
Ma'am.
rho L by A means √2 into 8. Yes, any question?
ম্যাম এখানে যে যদি আমরা দুইটা ফেজের মধ্যে I8 এর জায়গায় যদি I8 হাফ যদি ফ্লো করে তাহলে তো ম্যাম নিউট্রাল ওয়ারে কারেন্ট আবার আনব্যালেন্স চলে আসবে মানে এখানে যেরকম বলা আছে
না না I8 টা তো একটা আরবিট্রারি কোয়ান্টিটি, যে কোনো কোয়ান্টিটি হতে পারে।
ম্যাম
I8 টাকে আবার হাফ করবে কেন?
ম্যাম যদি ফ্লো করে এরকম লোডে যদি লাগানো থাকে এরকম যদি হাফ কারেন্ট ফ্লো করে তাহলে ম্যাম নিউট্রাল তো আবার
হ্যাঁ।
আনব্যালেন্স চলে আসবে
হাফ কারেন্ট ফ্লো করলে I8 by 2, এখানেও কি হবে √2 into I8 by 2 ফ্লো করবে, তাই না?
আচ্ছা।
কিন্তু সব সময় এটা √2 টাইমস তো ফ্লো করবে, এইগুলো তো যাই ফ্লো করবে,
হ্যাঁ,
কমাও
হ্যাঁ।
বাড়াও, তাই না? কমাও
এটা
আর বাড়াও।
কারেন্ট
হ্যাঁ, বলো।
ডিপেন্ড করছে ম্যাম পাওয়ারের উপর, বিকজ আমরা পাওয়ার আর
হ্যাঁ,
voltage তো constant।
পাওয়ারটা কনস্ট্যান্ট ধরেছে, পাওয়ারের উপর ডিপেন্ড করছে, অফকোর্স। যেরকম পাওয়ার থাকবে সেরকম ভাবেই কারেন্টটা ক্যালকুলেট
Yes,
করতে
ma'am.
হবে। তো রেজিস্ট্যান্স অফ দ্য নিউট্রাল ওয়্যার এত কমে গেল √2 টাইমস, ঠিক আছে? তাহলে লাইন লসটা আলাদা করে ক্যালকুলেট করতে হবে। কিভাবে ক্যালকুলেট করতে হবে? লাইন লস উইল বি I8 square R8 plus I8 square R8 because these two phases are identical. Okay, plus IN square into RN. এই পাওয়ারটাও নিতে হবে সেপারেটলি। So it will be actually total power loss will be 2 I8 square into R8 plus √2 into I8 whole square into Rn. I am considering Rn to be the resistance of the neutral conductor. So it is written like this: 2 into I8 square R8 plus √2 I8 square into R8 by √2, because R8 by √2 is the resistance of the neutral wire. This step is clear?
Yes, ma'am.
This step
Yes,
is
ma'am.
clear?
Yes, ma'am.
Other,
Yes, ma'am.
other things you can easily write down. You take I8 by I8 square R8 common. Inside it will be remaining, and P loss you can ultimately express like this. Just substitution, nothing else. Then what is 8? 8 is like this, and sorry, 8 like this. Now volume of conductor material, you have to consider the volume of all the three conductors. That means twice into 8 into L plus this one.
Root 2
8,
to 8.
yes.
Root to 8L.
Yes, root 2 into 8 into 8 into L, like this. So you take 8L common, and ultimately you do it later on. You will be finding, you are getting in terms of K, you are getting 1.457. So if we
Yes, ma'am.
compare only the two-phase system, it is 1.457, and previous one was 0.5. Okay, so this one was 0.5. This is more.
Almost 3 times.
Okay.
Yes,
So
ma'am.
now the three-phase system, it is very simple. You all have idea three-phase system. So let us consider first three-phase three-wire. Transmission, for transmission, three-phase three-wire is normally used because no need of providing the fourth wire. Now this point is R. So what is the per phase power is P by 3. What is the voltage per phase? It is Vm by root 2. So P by 3 equal to Vm by root 2 I9 cos phi. Simple. Okay. So P by 3 equal to Vm by root 2 I9 cos phi. You express this one, power loss will be same in all the three conductors. 3 I9 square into R9. So you just substitute R9, I9, will be getting A9 like this. Volume of conductor material, it will be 3 times of each phase, 3 conductors thrice into A into L, because 3 conductors, similar conductors, so 3 into A into L, like this. So ultimately, you'll be getting conductor A by 2 cos square phi. This is very simple. And three-phase four-wire, it is also simple. This in three-phase four-wire, this fourth wire will be available, but other will be remaining same, because in the neutral wire, under balanced condition, no current will flow. And we have seen earlier, if the neutral current is 0 under balanced condition, then cross-sectional area of the neutral conductor is considered to be half of the outer conductor. So initial treatment are same, exactly that of the previous one, this one. So up to this it will be same. Only in case of volume we have to consider 3.5 instead of, because there are 4 conductors. See here it is written. So it is 7 by 12.
Yes,
7 by 12 again it means approximately 0.6. Okay.
Yes, ma'am.
This watch these values in the tabular form. Yes, in the tabular form. See, maximum voltage between conductor and earth. This is the overhead system. Maximum voltage between conductor and earth. In the tabular form, everything is written here. So you can easily understand that, you can easily see if this is 2 wire is considered as 1. Okay, so it is considered 1.
Yes, ma'am.
It is 0.25. If this is considered as reference, this is like this. Okay, these will be still less than 2, more than 2, because cos square phi will be less than 1. Okay, so you can get an idea of the amount of conductor material requirement. This is 2-phase system, and 3-phase system is like coming like this. Okay, so now, so this is over. Let us just go through, discuss only one problem. How the problems, what type of problems you may get in the semester. Because in the problems you may find, first thing, if it is not mentioned about the cross-sectional area of neutral conductor, you consider it to be 0.5 half. And if it is not mentioned about the cross-sectional area of any conductor, you consider the cross-sectional area in terms of same current density. You consider current density to be same. Okay, if you find any data is missing, you consider current density to be same and proceed. If data is not missing, it is kept intention. It is not given intentionally so that you know how to consider. So current density you should consider to be fixed, and the power given is always the total power. You keep it in mind, and if it is mentioned that say the fourth wire in three-phase system is same cross-sectional area, then you have to consider instead of 3.5, you have to consider 4 into L. Okay. Now let us consider one typical problem, that is a three-wire DC system is connected to a three-phase, is converted to a three-phase four-wire AC system. See, there was a system, DC system of three-wire. Okay. Now it is converted to three-phase four-wire system. Four-wire means an extra wire is required. So an extra wire is added, and instead of DC, AC current is flown. So it is converted into AC four-wire system by addition of another wire of equal in cross section to that of the outers. Okay, so the fourth wire is of same cross sectional area. Find the percentage additional load that can be supplied for the same effective voltage between outers and neutral at the consumer terminals and the percentage loss. So they have asked to find out what additional load that AC system can supply with respect to the old DC system. Okay, by converting DC system to AC system, what additional power can be supplied? Load means power. This you have to find out. And some conditions are given. What are the conditions? First, effective voltage between outer and neutral is same. Okay, that means the neutral means the earth point is connected to the earth. So between outer and neutral, that means till now you have considered the outer voltage between outer and neutral. Sometimes for derivation you are not, it is not mentioned, it is whether it is underground or overhead system. It will be only mentioned where you consider the voltage between two conductors same, or the voltage between one conductor and an earth same. Okay, then you can easily consider that V in terms of what is given. So here voltage between a conductor and outer and neutral is given, that we have seen. Till now we have discussed considering this voltage only. And consumers at consumer terminals, percentage loss. Percentage loss means P loss by P. Power loss by total power, that is the percentage loss. So percentage loss in both the system is considered to be same. And another thing is given for a system, the power factor is given. Okay. Suppose power factor is not given, then you can consider it to be 1 and proceed. Now for three-phase system, what have you have to consider voltage between the outer and the neutral.
ম্যাম এখানে তো এসি সিস্টেমের লোডটা ব্যালেন্স দেওয়া, তোমার তো এই নিউট্রাল ওয়্যার দিয়ে কারেন্ট ফ্লো হবে না।
হ্যাঁ, হবে না, ঠিক আছে, কিন্তু সেখানে তুমি 3.5 ধরতে পারবে না। এখানে তো বলে দিয়েছে আউটার কন্ডাক্ট, ওই যে ইকুয়াল ইন ক্রস সেকশন এরিয়া অফ আউটার কন্ডাক্টরস, ঠিক আছে। এখানে তোমার অ্যাকচুয়ালি ধরারই দরকার নেই। তিনটে কন্ডাক্টর ছিল ডিসিতে, তিনটে কন্ডাক্টর নিশ্চয়ই একই রকম ক্রস সেকশনাল এরিয়া ছিল, আরেকটা কন্ডাক্টর তুমি যোগ করলে একই রকম ক্রস সেকশনাল এরিয়া, ঠিক আছে। আচ্ছা, ধরতে যেটা হবে সেটা হচ্ছে ভোল্টেজ। এখানে কিন্তু ম্যাক্সিমাম ভোল্টেজ বলা নেই, ভোল্টেজ বলা আছে। সো কনসিডার ইট অ্যাজ আরএমএস। যখন আমরা শুধু ভোল্টেজ বলি, ভোল্টেজ ইন আওয়ার হাউস ইজ 230 volts, then what do you mean by that? It is only RMS voltage.
Yes.
Maximum voltage is √2 into 230. But here it is said voltage, that means you consider it as RMS voltage. এখানে আবার √2 দিয়ে ভাগ গুণ এসব করতে যাও না। যেমন প্রবলেম থাকবে সেরকম ভাবে তোমাকে ট্রিটমেন্ট করতে হবে, ঠিক আছে। তুমি যদি বলো না আমি ম্যাক্সিমাম ধরে করেছি, এখানে ম্যাক্সিমাম ধরে করবো, তাহলে কিন্তু হবে না। যা বলা আছে সেটাকেই তোমাকে ট্রু ধরে প্রবলেমটা সলভ করতে হবে। So in DC3 system, power is twice V into I1. Okay, so voltage between conductor and earth twice V তো সবসময় হবে, কারণ এটা তো দেখেই বুঝতে পারছো 3 watt DC 3 watt DC মানে হচ্ছে তোমার এইটা twice V থাকবে, VM এর জায়গায় V থাকবে, আর কিছু নয়। So for DC P1 equal to P1 মানে ফার্স্ট সিস্টেম বলে P1 দেওয়া হচ্ছে twice V into I1। পাওয়ার লস কি হবে? দুটো কন্ডাক্টর, থার্ড কন্ডাক্টরে কোনো লস নেই যেহেতু কিছু নেই, পাওয়ার লস twice I1 square R, পার্সেন্টেজ পাওয়ার লস হচ্ছে twice I1 square by this one। আমি বলেছি পার্সেন্টেজ পাওয়ার লস হয় P loss by P1। পার্সেন্টেজ পাওয়ার লসটা কেন ক্যালকুলেট করছি? কারণ এখানে বলে দেওয়া আছে the percentage loss is same, so we are calculating the percentage loss, the percentage power loss. Now consider the AC 3-phase 4-wire AC system. Three-phase 4-wire AC system, power supplied is 3 V phase. This is V phase, isn't it? Because it is a voltage between the conductor and the earth, between outer and neutral. So it is 3 V I cos phi. V is the RMS voltage given, and cos phi is given 0.95. So you write 95, it will be like this. What is the loss? Loss, you know, 3I square R. So it is considered as 3I2 square into R. Power loss is 3I2 square into R. So percentage power loss will be 3I2 square R by this one, P loss by P. So here percentage power loss is this one. Now it is given that percentage power loss in the two systems are same. So this one will be equal to this one. Okay, equate this one and this one. What is our objective? Our objective actually is to express P2 in terms of P1. That means we want to find out whether additional load, what additional load this 3-phase 4-wire system can supply with respect to this one. See, additional load is given. If it comes as negative, then you can understand it is not additional, the load is reduced. Okay, you can write that one also. It is not that always will be getting positive answer. Maybe there is reduction in load. You can also find out that. So percentage power loss, we equate these two. And what we get? We get I2 in terms of I1. If we get I2 in terms of I1, we can easily substitute I2 here. If we substitute I2 in terms of I1, then what we get? See, P2 is 2.85 V into 0.95 I1. So it is coming as 2.71 VI1. And what was P1? P1 was simply twice VI1. So, and it is 2.71 VI1. So you can understand P2 is more than P1. But what additional load? Additional load will be P2 minus P1 by P1. So it will be 35.5%. Understood?
Yes, ma'am.
So this is a typical problem. I'll discuss more problems in the next class. So you go through the derivations thoroughly. So if you go to the derivations, then you will be able to understand everything. I will solve more problems in the next class, and I will supply this problem sheet. I will supply in the next class. Today I will give you this class notes. Hope you have got the class notes of the last class.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So you will be coming to the college next week, some of you. For the first time, probably. For the first time, isn't it? You were not called earlier.
No, for lab we have attended.
Well, lab.
Yes.
Okay,
ma'am.
okay. You attended some lab. Anyway, hope everything will get normalized. Anyway,
Yes, ma'am.
so let's end the class today here. Okay. So
ম্যাম আমাদের ক্লাসগুলো কিরকম ম্যাম? মানে ওই সিডি করে সিটগুলো থাকে ওইরকম না এমনি নরমাল বেঞ্চ বসানো আছে?
না, তোমাদের ক্লাসগুলো তোমরা সেকেন্ড ইয়ার, তো সেকেন্ড ইয়ার ক্লাস হচ্ছে একতলায়। এমনিতে আমাদের ক্লাসরুম গুলো সব এসি, আন্ডার গ্রাজুয়েট ক্লাসরুম গুলো একদম একতলায়, একদম কর্নারে, মানে ঢুকে একদম মানে ধরো একদম এন্ডে আর কি, মানে ফার্স্ট ইয়ার আর সেকেন্ড ইয়ার হচ্ছে গ্রাউন্ড ফ্লোরে, থার্ড ইয়ার হচ্ছে ফার্স্ট ফ্লোরে, আর ফাইনাল ইয়ার হচ্ছে একদম সেকেন্ড ফ্লোরে। ঠিক আছে?
ওকে ম্যাম, ইয়েস ম্যাম।
তোমাদের এমনি বেঞ্চ দেওয়া
একতলায় মানে ম্যাম মেশিন ল্যাবটা পেরিয়ে?
হ্যাঁ, মেশিন ল্যাবের পেছন দিকে, মানে মেশিন ল্যাবটাকে তোমার মেশিন ল্যাবে দুদিকে যাওয়া যায়, একটা মেশিন ল্যাবের বাঁ দিক দিয়ে যাওয়া যায়, একটা ডান দিক দিয়ে যাওয়া যায়। হ্যাঁ, ডান দিক দিয়ে গেলে তোমাদের ফার্স্ট ইয়ার, তোমাদের বাঁ দিক দিয়ে গেলে বাঁ দিকে হচ্ছে সেকেন্ড ইয়ারের রুম। এমনি পুরোটাই পেছন দিয়ে গ্রাউন্ড করে ঘুরে আসা যায়। ঠিক আছে? ওকে,
থ্যাংক ইউ
অল।
থ্যাংক ইউ ম্যাম।
থ্যাংক ইউ ম্যাম।
Thank you.
থ্যাংক ইউ ম্যাম।